Now, kind of the second part of 3.1 and factoring is factoring special products. So of the products, you kind of have it in two categories. You have the squared category that's right here, and then, so these are all of dealing with all of your squares in this part. Okay, and then you have kind of your other section that deals all with sum and difference of cubes. Okay, so whenever it's a sum and a difference of cubes, then it's going to be a perfect cube, or it'll have probably an x or an n or whatever variable we're using to the third power. Okay, and then what we're doing is we're looking for perfect cubes. So like 2 cubed is 8. So perfect cubes are 1, 8, 27, 64, 125, 216, so on and so forth. Those are the numbers that they get multiplied by a constant number 3 times instead of a square where it gets multiplied by itself twice. Okay, so whenever we deal with difference of squares, difference of 2 squares will always have 2 values. Okay, and that's it. If it's a perfect square trinomial, then it is a trinomial, so it'll still have 3 terms. Okay, the trinomial, you can still factor it the same way we did with the x and going through your a and your c and multiplying those, and then the b and what needs to happen to either add or subtract. The only thing here is always look with any sort of trinomial to see if the first term is a perfect square and if the last term is a perfect square. If it is, that's what I want to try first, because some of those numbers can get really big really fast, and I want to try to keep that from happening. Okay, so what's going to happen is, if I have 2 values, so I have x squared minus 16, I have 2 values, so difference of 2 squares. The first thing I want to do is check to see, is 49x squared a perfect square? Well, yes it is. Is 16 a perfect square? Yes it is. Do I have a minus or a subtraction in the middle? Yes I do. So it's going to be a difference of 2 squares. So if it's a difference of 2 squares, I'm looking for 2 values that I can find, or really the same value, that's going to multiply by itself to be 49x squared. Well, what number multiplied by itself gives me 49? Well, that would be 7x and then 7x. Okay? Everything here with a difference of 2 squares, they're going to match, or they're really what's going to be called conjugates of one another. So then, same way, 16. What are 2 numbers that are going to multiply together to give me 16? Well, 4 and 4. Since I don't have a b in the middle, since that goes away, what's going to happen is I'm going to have one that's going to be positive and one that's going to be negative. Okay, they're actually what's called conjugates, and we'll talk more about those later, okay, as we get it further into the chapter. But that's all I've got to do. I just have to find what's the square root of 49x squared. Well, it's 7x. What's the square root of 16? It's 4. So then I have a positive and a negative version of it. Same way over here with 9n squared and 25. I have a subtraction. Both are perfect squares, so what number times itself gives me 9n? Well, 3n. What number times itself gives me 25? That would be 5. So I'm going to write the same 2 values. The only thing that I'm going to do that's different is one's going to be a positive and one's going to be a negative. Okay, that's all that should happen. You can still do these the same way, just like we did here. Okay, you can do it this way to where I take 9 times 25. I wouldn't suggest it, because then I have a 0 down here for the b. But if I'm going to multiply a times c, okay, and the reason why this is a nice little shortcut, I want to try to keep this from happening. So if I do, I'm going to have 225. I'm looking for all the factors of 225. There's a lot of factors here, okay, that I don't really want to deal with. Okay, because I'm going to go all the way through my list, and I'm looking for 2 numbers that have to be the same. So if I'm looking for 2 numbers, well, that's 15 and 15. So it would work out to be the same thing if I have 15. One needs to be a positive 15, one needs to be a negative 15. I would still do it, but I would pretty well have to go all the way through my list, and I want to try to keep that from happening. If I can shortcut this, I'm going to shortcut it. Same way with a perfect square trinomial. So it is a perfect square trinomial. I could take 16 and 25 and multiply those two values together. I want to try to keep from having to do that because I don't want to have to figure out all the different factors of 400. Okay, if I have to find all the factors of 400 and then combine to give me 40, okay, that in itself is going to be a little more difficult. Okay, what I want to do is I want to look, is that a perfect square? Why, yes it is. Is this a perfect square? Why, yes it is. We've already talked about that. Depending on what the sign is right here in the middle, if that's a plus, the first thing I want to do is to check and see, okay, what number times itself gives me 16y squared? Well, 4y. What number times itself gives me a positive 25? Well, a positive 5. Can I multiply 4y plus 5 and do it again? Okay. Or 4y plus 5, quantity squared. An easy way to check to see is ask yourself, is 4y times itself 16y? Yes, it is. Is then 5 times itself positive 25? Yes, it is. Now, the middle part's a little bit tougher, but it's really quite simple if you just let it be. What's 4y times positive 5? Well, that is 20y. Take that 2 and multiply it by 2 and we get 40y. We get that number that's in the middle. Okay, that's really how that comes from as far as our shortcut. If we can multiply those two numbers, that 4y and the 5 together, and then double it, then we can help ourselves and shortcut this a lot easier. Now, on 6, it should have been negative 1y squared. It didn't print and didn't make it, and I apologize for that. But again, the same thing. What number times itself gives you 36? Is that a perfect square? Yes, it is. Is this a perfect square? Yes, it is. So, now that should be a plus 1y squared. I don't know why it was a negative. So, plus 1y squared. So, two numbers that are perfect squares of 36x. So, I have 6x and 6x. So since this is a negative, that means that both of these signs in here will be a negative. 1y and 1y. Okay, because 1y and 1y, negative 1y and negative 1y multiplied together will give me a positive 1y squared. Okay, again, easy way to check. What's 6x times negative 1x? Well, it's negative 6. Double it, gives me the negative 12 that I'm looking for. I'm okay with you leaving it like this here. Okay? Or if you want to rewrite it as 6x minus y quantity squared, since you have two of them, that works as well. Either answer is okay by me. Now, the last two deal with sum and a difference of two squares. So, an easy thing to kind of remember with the sum and a difference of two squares is SOAP. Okay? With SOAP, that just means it's going to be the same sign. It's going to be then the opposite sign. And then the last part is going to be always positive. So what that means is, since it's a perfect cube, so if it's a perfect cube, if you noticed up above we had, if it was a to the third plus b to the third, and then if we had a to the third minus b to the third. So what I want to do, I want to find what number times itself gives me a and what number times itself gives me b. Notice that whenever we talk about same, that means that the same sign, if it's a negative, okay, if it's a negative, that's a negative. If it's a positive, that's a positive. So then in my second parenthesis, I'm going to take a squared, opposite sign, so it's going to be negative ab, and then always positive b squared. Same way in the other one, I'm going to have a squared, opposite sign, so plus ab, and then plus always positive b squared. So from there, I need to figure out what are a few of my perfect square, or perfect cubes rather. So a few that you need to probably remember are going to be 1, then 2 to the third is going to be 8. I have 27, 64, 125, 216, 343, and then what, 512, 729, and 1,000. So those are just the first 10. I would make sure you can memorize those and know exactly what they are. Obviously they go in order as far as 1 to the third, 2 to the third, 3 to the third, so on and so forth. But those are your first 10 perfect cubes that you're going to need to memorize and know kind of off the top of your head from there. So if I have 64x to the third, I need to figure out which number, is it a perfect cube? Yes, or it wouldn't be here. So I have 64 right here. So it's the fourth one, so that means I'm going to have 4x, okay, because 4x times itself 3 times gives me 64x to the third. Now, SOAP, so same sign, so minus, and then same way with the 27, so there's the 27, so it's third in my list. So I have 4x minus 3. Now, the second part, and I'm going to kind of overwork this problem, and what I mean by that is I'm going to show you all the steps. And the biggest part that you've got to remember is that whenever we deal with A and B, I'm not worried about my sign. Like, this is just A, that's just B. I'm not worried about making it a negative 3. I'm taking it as B as being a 3, not the sign. I'm not taking the sign with me because I'm already going to change things as I go. So whenever I do, if I just take my formula, I'm going to have a squared. So what's a squared? Well, it's the 4x that I have there. Okay? Minus a times b. So 4x times 3, and then plus, because I switched the sign, so plus b squared. So plus, and then b, so 3 squared. Now, you can multiply 4 and negative 3, you're going to get the same thing. Okay? It just kind of helps shape the problem a little bit better if we just go ahead and multiply it. So if I have, so the 4x minus 3, nothing changes. Then 4x squared, so 16x squared, minus 12x, and then plus 9. Now, again, if you want to take the sign, that's fine, but just make sure all I'm doing really here, okay, it just really shows you that it should be an opposite sign. If I want to take 4x times negative 3, it's still negative 12. If I want to take negative 3 and square it, it's still going to be a positive 9. That's okay. Okay, alright? So either do one or the other, either multiply both parts together or just stick with the number. So whenever I have 8x to the third, and I have 125y to the third. So number times itself to give me 8x to the third is going to be 2x plus, because it's the same sign, and then 125y is going to be plus 5y. So for the second part, I'm going to kind of just talk you through this second part. So once I get here, 2x squared, so I have 2x squared. Then I can just take it, I can take 2x times 5y, okay, and make it a plus. It doesn't matter. 2x, 5y, multiply those two together, plus, if you do it this way, always keep it a plus and then change your sign if you need to. And then have 5y quantity squared. Sorry, I should have made that a bracket. So the front side of my problem doesn't change. So it's still just going to be 2x plus 5y then in the second parenthesis I'm going to have 4x squared. Oop, should have, my mistake. Two x plus 5y is 10xy plus 25y squared. Kayla Shelton, everybody.